Okay, here's the lecture. This is going to be lecture 5. Counterfactuals, antecedent, consequent, conditional assertions, and that conditionship. I'm just going to run right through this, and I'm going to leave it up to you to keep up. I'll go slow as I can, but you'll keep up. I'm sure you'll keep up, and you'll find out, for those who aren't totally familiar with this form of logic anyway. Decoding assertions of conditionality. Games. First game, we can set up all games possible for the contrary to fact and conditional situations. 2, one key assertion that we want to crack is whether the modality of helping verbs, that is to say auxiliary verbs like should, could, would, and can, for example, are a function of conditionship logic, or is conditionship logic a function of the mode of the auxiliary verb, such as the subjunctive. It carries all of those modes: could, should, would, can, and so on. They have their different tenses and so on, but they're all modes. They're modality, tense, mood, aspect. That's all there is around a verb, or tense, modality, aspect. Okay, i.e. a verb, so, or is conditionship logic a function of the mode of the auxiliary verb, i.e. a verb is the subjunctive mood, but it is acting as a helping verb. I think that's pretty clear. Anyway, we have to decode which one of those first 2 items is true. 3, I draw on the blackbird on the blackboard a duck. We already know about that. But what we're going to do, the duck rabbit, we're going to assign peripheralities. The duck is the duck peripheral. The rabbit is the rabbit peripheral. We put herd up there, and we have an intimate relationship when we see peripheral duck, let's say peripheral 2 or peripheral B. We process the sentence very quickly when we see the word herd. Or we process the association. When we see duck, we do not process it. So we do not have an intimate relationship between 2 items, P and Q, or that is to say, one peripheral and the behavioral word, herd in this case. Okay. Now, contrary to fact conditionals. That we may be able to assert a mechanical, now this is my writing, that's why I'm so good. That we may be able to assert, after all these years, that we may be able to assert a mechanical connection between an antecedent and a consequent. That is truly to be one in which we can assert Py on the condition Qy, i.e. to assert y of P on the condition y of Q. There must be a non-logical ground for this assertion. Otherwise we can't make it. Remember herd and the peripheral, where it works with. That's not a logical relationship. It's a linguistic relationship. Got it? Okay. And we continue in that vein. Okay. Then we are able to assert a conditionship relation that approximates a counterfactual conditional assertion of P of y on the counterfactual condition Q of y. That would have to be grounded on a non-logical, causal, or mechanical connection of conditionship between P and Q. So that whatever holds of P must also hold of Q, given a context of a peripheral aspect-seeing object, duck rabbit, and a behavioral word, herd. Indeed, everything which is P is Q. And for all that is not P, if it had been, it would have been Q. and the connection of the conditionship between the two would exert itself. This would be loyal to the quantification for all x p of x then q of x. The connection of conditionship between p and q would be absolutely required then to assert the consequent assertion that if x had been p, it would also have been q. So if we didn't have heard up there, but we had whatever the behavioral verb is for how ducks move, we would not have the intimate counterfactual relationship between the two items between the alternative items of a rabbit and a herd. No, we'd indeed be seeing that which is between the duck and its behavioral mode of movement, or any other behavior that it may have. Aristotle classified these things. We can dig them up. So, in other words, now, we can undermine this. We can say that there is, we can simply invoke the existence property with the disjunction property and assert that for all x cube x. Well, in which case, there's nothing. There's no binding between q and one individual item. There's no peripheral. There either exists no peripheral there, and there exists the word heard there, or there exists the word heard there, but no peripheral. And indeed, the peripheral has to be there. It has to be a visual vulnerability. This is a vulnerability, by the way. Aspect-seeing the duck rabbit is a vulnerability. It tricks our perception. We put it in order when we have the right behavioral word there, which we all know about birds and bison. For example, if we saw the rabbit as a bison. But fine. Okay. So we can undermine this again by invoking the existence and the disjunction property and assert that for all x cube x. We just went over that. In other words, we can undermine it by saying there is an x in the range of expressions out there where we assert a phi of x where phi has no other free variable than q. And that's it. P, Q. Phi is P. And phi, that is to say, Q has no other free variable than Q. So let me repeat this. We're stating this in a translational language, in a sort of a meta language, but we have to. So it is easy to undermine this, that if x had been P, it would also be Q. We would simply invoke the existence property or witness property and the disjunction property, which go together, and assert that for all x cubed x. In other words, there would be an x, such that in the range of expressions there is a phi of x, where phi has no other free variable than q. Then it would prove that phi is out there for a range of expressions, and it can be represented by a term. Now, when we get to that point, we are actually not undermining it. We are stating that there's a term out there that actually defines this relationship. Okay. So we undermine it by saying for all x cubed x. We assert it, I'm contradicting myself a little bit because I have to go fast. We assert it by saying that there is an x such that for the range of linguistic expressions there is a phi of x, where phi has no other free variable than q. Okay. This asserts it, it doesn't undermine it. Then it proves that phi, in the range of numerical or in the range of linguistic expressions out there is a member of those things which pertain to the which pertain to the existing property, and then therefore we have a term representing it. Now, in other words, Q will hold of X no matter what holds of X, be it P or anything else. Excuse me. That is undermining it. So both expressions, it's easy to undermine that if X had been P, it would also have been Q. Okay? It's easy to undermine it by invoking the existence property and stating for all X, Q of X. In other words, there is an X out there in the range of expressions such that phi of X, where phi has no other free variable than Q. Then the conditionship relationship between P and Q holds. Then it also proves that there's something out there where Q will hold of X no matter what holds of X, be it P or anything else. And that is a term. We don't need to go into that. Okay, excuse me for the confusions. Even I get confused. I'm human. It's also possible to undermine the conditionship relation between P and Q like this. So there's not an X such that P of X. Okay? So if there's not an X such that P of X, well, you don't have a P to work with for a Q to work with. In rather the same fashion, but this is reverse engineered, so to speak. Okay. What, however, if P of X suddenly presents itself from out of the blue? Will the conditionship relationship between P and Q still, in parentheses, hold, or did it ever, in parentheses? And if so, in the first place, why? And second, because we might want to establish if it ever had. We might want to establish if it ever had. Okay. Now, the next point, which is actually the sixth point. We might answer that question with the use and invocation of inhabited sets. Say that one or more of the supersets of a superset's members are active agents, and thus they can be productive somehow. The set has variables or objects, or properties of objects, or a singleton, or singleton strings as its members. And the empty set is a unique and single other member. Okay. So you have the superset, you have the set, which are the singletons A, B, C, and D, and you have subsets, and you also have the null set. Now, with respect to this, we can make an effort to redefine the existence property or the witness property, which might give us a more definitive marking to look for in this new and novel view. In other words, a set can be generative. So we might want to answer the question, did it ever hold? Yeah? What, however, if P of X suddenly presents itself from out of the blue? It falls from the sky. Will the conditionship relation of P and Q still hold? Or did it ever? And if so, in the first place, why? And secondly, because we might want to establish if it ever had? Well, I'm not going to go into the details of the set theoretical point of view where, yes, we can establish whether it ever had if we look at set theory. Intuitionist sets are inhabited sets, they're called, and they do have the power of generation. The way that I just explained sets wasn't too good because I'm in a hurry, but intuitionist sets do have the power to generate new objects ad infinitum. And that's just a fact. Okay, Now, that that is really all that we have. I have a little note here. I can define the unnecessity of von Wrieg's use of a functor and substitutability in his solution to the heterological paradox by observing an inhabited set. That's just a note. Okay. Now, what I have to do is extract Julian Boyd's subjunctive modal helping verbs, auxiliary verbs, to von Wrieg's contrary to fact conditional assertions and his heterological system or paradox. That's what we have to do, and that's done, and it's next. I hope this has been slightly understandable and comprehensible.